goes to infinity goes to 0, you will have to pick another test. Okay, so I'm going to fill that in. If the limit as n goes to infinity goes to 0, pick another test. You will usually end up having to use L'Hopital's to apply this because a lot of times you will get infinity over infinity, and then you will have to apply L'Hopital's until you come down to a final answer.
But doesn't that say is equal to 0?
So if the limit of your general term is 0, you have to pick another test. It doesn't tell you that it converges.
Oh, well, okay, wait.
So up here,
Yeah.
if the limit goes to anything other than 0, diverges.
Oh, that's so okay, that makes sense. Okay, just kidding. I was missing that.
If the limit goes to 0, you cannot say that it converges, and we'll do more examples where like these 3 all go to 0 and like one converges, one diverges, and like it's not always the same. So if it doesn't go to 0, diverges.
Okay.
If it goes to 0, pick another test.
Okay.
Okay. All right, so that is our nth term test. And then the last one will show up on the free response, I would say 90% of the time. Okay, so there are certain ones where I'm like, make sure if all else fails and you can only remember 3, this next one is one of the 3 to remember. And it's the ratio test. You're just going to love it.
Is that sarcastic?
Totally.
I was going to say, these two don't seem too hard.
No, they're not bad. It's honestly, none of the tests are bad. It's when you have 9 different tests that you can choose from, that's what makes it thoughtful. But with the order that I'm giving them to you is generally the order that I go in. First, I check for geometric because that would be a dream just to say r is less than or greater than 1. And then the nth term test, the limit to infinity, is generally pretty easy. This would not necessarily be my next pick, but it, however, does show up most often. So I'm going to put it in. All right, so if you have a series with positive terms, and this is how you apply the ratio test. So first of all, you need to look at it. It needs to be positive terms. If not, we have things like the alternating series test. We have other ways to test it, but if it is always positive terms, and with the limit as n goes to infinity, so we're going to just actually get to use some L'Hopital's at very fantastic times. You have to take the ratio. Let me write that clearer because that's a subscript, you guys. So you have to take the limit, the ratio of the next term to your original term. So we will do whatever the general term is. We'll go on bottom. In the general term, everywhere where there were n's, we will replace them with n plus 1s, and that's what will go on top. So I will do that one in detail for you. When you do that, you will get some number at the end. Then we have 3 options. So the ratio test, you will have to do this, you guys, seriously, on the free response. Like 95% of the time, you have to start with the ratio test. So you need to make sure you're amazing at the ratio test. Okay. So when you do the ratio test, you take the ratio of the next term to the previous term, you take the limit as you go to infinity, and you will get a numeric value. Okay. When you do that, the series converges. If the absolute value of L is less than 1. So when you take the ratio of the next term to the previous term and your L is less than 1, your series converges. The series diverges. If the absolute value of your L is greater than 1. last one is the worst option ever. If it equals 1,
Then you have to pick a different test.
pick another test. And it's crappy because this actually takes a substantial amount of time to do the ratio test, and you get to the end, you're like, okay. So, and if your limit equals 1, picking another test is not exactly enjoyable.
But it's the ratio test the only one that can tell you for sure that it converges.
No, the nth term test can only tell about divergence. The other test can tell converge or diverge.
Wait, Logan, what did you say?
Is it the absolute value?
Okay.
Okay.
It's because they're always positive terms.
Yeah.
Oh.
It's going to be 1, but if it makes you feel better, put the absolute value in there, then go for it.
Alright, yeah.
Okay, those are the only 3 tests we're going to do today. Okay, the trick is knowing when to choose. So back up. Geometric. What is going to like jump at you and go like, oh, I should start with geometric?
And it's in the
If n is only in the exponent, I would start with geometric. If you have n in the exponent and then it's in the denominator as a coefficient, it cannot be geometric. Okay, so that's checked off. If it looks fairly easy to take the limit as n goes to infinity, and like keeping in mind that you're probably going to have to use L'Hopital's at some point, this is not a bad test. Okay. The other one, typically, or I would say quite often, like the hint to use it, not always, but this would definitely be where I would start if I saw this. If you have n factorial, I would definitely start with ratio test. So that would be, like if I only have n's in the exponent, I'm going to go to geometric. If I have an n factorial, I am probably going to skip straight to the ratio test. And then you guys, we have tons more tests, so today we're going to focus on these 3. Focus on telling converge or diverge and make sure that we understand our conditions that have to be met. Then tomorrow we'll work on the radius and the interval of convergence. And then the last 2 days we will spend with the other tests, and then we have to check at the ends if they converge at the ends of the interval. The reason why we didn't have to check, go away. The reason why we never checked when we did geometric, we never checked the endpoints. We just said it went from like whatever, -1 to 3. It's because the endpoints always made your ratio equal to 1. So we never had to check the ends when we did the geometric series. If it is a geometric, you don't have to check the ends. The ends always make your ratio equal to 1, and so it's always diverge. Okay, so we're going to get there. So for today, these 3 tests, we're going to tell converge or diverge, and we're going to talk about the conditions. So let's do
What?
some
I'm
samples.
confused by the endpoints. What are you talking about the endpoints?
We'll get there.
Okay.
All we're going to do is tell converge or diverge and state the test and the conditions. So first of all, we have pecking order. Geometric.
No.
Okay, so then it's nth term test or ratio test. And if there's a factorial, I will jump straight to ratio test. If there's not, I'm going to start with the nth term test.
So would you, the way you do it, do you like to write what test you're doing and then?
When my kids take the quiz, or when they take the test, and also when they take the AP test, they write down all of the tests in like their preference order, and they just kind of go down and mark them off as they go. Most people in here are like checklist kind of people, like first I do this, and then I do this, and then I do this. This totally suits that person. If you're like oh, well, but maybe, like I love Muns to death, this would be like the death to her because she's like here, and then she's here, oh, and I forgot about this, and you are so screwed if that's how your brain works. Like your brain can't be mishmash, it's got to be like the first this, and then this, and then this, and it's not really that bad. All right, so checked off, no geometric. Okay, no n factorial, so I'm not jumping to the ratio test, so I'm going to try, bless you, the nth term test. So the nth term test tells me to take my general term, and try to take the limit as n goes to infinity. Okay. These usually result in L'Hopital. So when I look at this, I looked at things like n factorial. You can't do the nth term test because you don't know how to take the derivative for n factorial. Okay, so that is totally like,
I didn't
okay,
even think about that.
so there are things that it's like, oh, well, I couldn't do that even if I wanted
Can you
to.
take the derivative of factorial?
Of what?
Of a factorial, can you?
Well, of a number factorial,
Wouldn't it be
because it's just 0.
zero?
Like 3 factorial is the derivative is just
that
0.
makes sense.
Okay, so 2 to the infinity is the infinity. Infinity plus 1 is infinity. Shocking, we've got L'Hopitals. Apply L'Hopitals, and then check again.
So do you write like
Okay, you guys, you had need to know quizzes. How do you take the derivative for 2 to the n? No. It is not n 2 to the n minus 1.
Oh shoot!
Oh, I forgot
It's a
it. Oh, yeah.
constant.
My variable is in the exponent, you guys. My variable is not the base. It's not like I'm taking the
Is it
derivative of
just
x cubed. No, it is not just 2 to the
It
n.
has to do with an ln.
Pull out your green derivative sheets. Yeah, calculus I actually appreciate comes full circle a lot. Like, oh,
To
crap.
the n times n prime times ln of. Okay.
It is on your green sheet, you guys. What number was that, Logan?
It's a to the x.
We have to write it in next to the e to the u number 10.
Okay, so I asked you to write it in on your green sheet next to number 10.
So it's just 2 to the n. Hey Logan, is ln in for seasons?
It's just ln.
You don't need.
Okay, so Logan, the derivative for 2 to the n.
It's just minus ln.
Derivative,
So it's 2 to the n times 1 times ln of 5.
because when you have your exponential functions, it is that exponential function, the derivative of the exponent, ln of the base. It's why the derivative for e to the x is e to the x, because ln of e is 1 and the derivative of x is 1.
So
That is my top. I know, but you guys always
But, yeah.
know I give you credit for work. And the derivative of the bottom is,
1.
okay, and so now I need to reapply. Now what do you get when you plug in infinity?
It's infinity.
Okay, so now this is what you're going to write. Okay. My limit as n goes to infinity of a sub n was infinity, which is not 0, so it diverges.
You have to write all of this?
Yes, because you have to show me you knew the condition. Okay, you have to show me that you knew that any limit other than 0 was causing it to diverge. So you have to tell me converge or diverge, you have to tell me the test, and you have to tell me the condition of the test that was met. So the condition that was met was the limit of my general term as n went to infinity was not 0. Okay, so 3 pieces, converge or diverge, okay. The test, the conditions of the test. Okay, those are the 3 pieces I'm asking for because you have to be prepared on the free response on the AP test to tell converge or diverge, tell the test, and tell the condition of the test. Okay, so questions on this one, because I'm going to try to make sure I hit each test. You guys are solid on geometric, though. Okay, here we go. We're going to keep going then. Converge or diverge, and what test, and what condition. If your n is only in the exponent, that should be jumping out at you, you guys. When it is geometric for most of you, it will help to write out the first couple terms, especially since the follow-up is usually what is the sum, and you need the first and you need the ratio anyway. What is your ratio? It is 1/8. It is not that negative. The negative was not to the end. So your ratio is 1/8. If you wrote out the first couple terms, you will see that. Converge or diverge? Okay, so let's work on writing it. So the first thing that you have to tell me is converge or diverge. So you're going to converge. You're going to say by. What test?
Geometric.
Okay, so converge or diverge. Then tell the test. So it converges by geometric series. And then
Absolute value R is equal to 1/8 is less than 1.
okay, so three pieces always. Converge or diverge, the test, the condition. You guys should be solid on geometric. Like by now you should be like, oh, it was geometric, that's so fast. Like there's very little work that goes into it. I still do tend to write out the first couple of terms because then if they asked you to find the sum, how do you find the sum for this? A. So you needed this first term anyway. And you needed the ratio anyway. Okay, so when you were doing these problems, go ahead and write out the first couple of terms for geometric to make sure you are really seeing the ratio, and then usually the follow-up question is to find the sum anyway, so you're going to have that. All right, here we go. Again, you guys, it so doesn't matter that this one starts at 0 and the rest started at 1. Okay, so please don't stress on that. What is it not? Okay, so then from there, your choices are the nth term test or the ratio test. Those are your two choices that you have left. Look and think a couple steps ahead. Okay? When you plug in infinity, what are you going to be getting? Infinity over infinity. So derivative, what's the derivative of the top? Okay, so I'm going to do a couple and I'm going to show you, like, partway through, I am not going to finish this. I'm going to show you why. So I'm thinking ahead. So I've got a 10, an end of the ninth. What's on the bottom now?
10 times by L and 10.
You're just going to continually get infinity over infinity? Yeah.
Not continually. Because eventually, so my next one would then be 10 times 9 n to the 8th over this is just a constant, you guys. So I don't, it's not product rule down here. So then you're going to have an ln of 10.
Multiplied by the, oh man.
You're going to keep going. What's going to eventually happen on top?
Zero.
Okay, eventually on top, you're going to get a 0 on top, and eventually on the bottom, you're going to have
ln 10 to the
Infinity.
10.
ln 10 to the 10th, 10 to the n. So we can stop one short of getting to 0. What number would have been on top before when we took the derivative we got to 0?
10 factorial n.
Awesome, 10 factorial. And then the next one after I took that next derivative, so we would have had dot, 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 like a 10 factorial. Whoops. 10 factorial and a whole bunch of stuff on the bottom. The next derivative is going to be what on the top? 10 factorial. The stuff on the bottom is going to infinity. Where is this going?
0.
And what do you have to say when you hit 0?
Another test.
Please try to think a couple steps ahead. And if you're like,
I would not.
okay, the bottom's always going to be there, the top will eventually go away. If the top eventually goes to a number and the bottom is going to infinity, crap, I really don't want, you don't want to sit and take that derivative the whole time and then get to 0. Okay, so try your best to work a step ahead.
Oh man.
Okay, so big no on the nth term. Okay, so now let me show you how to do the ratio. The ratio test is we are taking the limit as n goes to infinity of a sub n plus 1 over a sub n. So the a sub n is your general term. Okay, so that part I'm just going to fill in. So I'm just going to put in. Okay, so the a sub n is my general term. To do a sub n plus 1, everywhere where I have an n, I replace it with an n plus 1. So coming back over here, here I have an n, it's now an n plus 1. The 10 stays because there was no n. The 10 stays because there's no n. This n becomes an n plus 1. Okay, so that's how you start the ratio test. We are still taking the limit as n goes to infinity. Algebra before calculus. Okay. So we've got a fraction over a fraction. So top divided by bottom is top times reciprocal. Okay. So top times reciprocal. Awesome. This, you can separate. Caffrey, tell me how to separate it. You had it.
You separate the 10n times 10, and then you can cancel
10 to the n plus 1 is the same as 10 to the n and 10 to the first. And that is really nice to remember. We are doing algebra before calculus. Okay, so when I take the limits, this is what I do. Numbers, regular numbers, I put them separate from the n's because I'm only taking the limit as n is going to infinity. Okay, so I'm going to break this apart and let me split screen so I can just keep working across. Okay, so from here, you guys, I have a 10 left on the bottom, so I'm going to put a 10 on the bottom, and then I'm going to group all of my n stuff together. It will make it easier for doing the limits. This has n in it, so I've got this. This has n in it, so I'm there. I am still doing the limit as n goes to infinity. So the 1/10 will come into play after I find this value. So for right now, I'm going to let the 1/10 hang there. I'm taking the limit as n goes to infinity. What's my problem? Okay, so you guys, you have choices. There are ways around it. There are ways to think ahead. I can look at it and tell you it's 1 for this piece. Back in the very beginning, when we were reviewing pre-calculus topics, if I gave you this, and I asked you for the horizontal asymptote, what do I do to find the horizontal asymptote?
It's like the ends are the same power. It's 0.
Oh my
Or 1.
gosh.
Just kidding. Sorry. And then too many on the bottom means you have to. Wait, is 0. And then too many on the top means there isn't 1.
Correct. Okay, but that's not going to help you because Kaylee's the only one that knows how to do it.
Yeah.
Okay, so now let's go back then if nobody's going to remember it and go back. When you plug in infinity, you have infinity over infinity. So your choices are to sit and do that derivative a whole bunch of times, or, you guys please look, these have the same power.
Yeah, you can choose.
Okay.
That is your best algebra option. If you're not going to remember the horizontal asymptote stuff, that is your best algebra option.
That is cool.
Thank you.
Whoa.
Yeah. Okay, so now you have infinity over infinity, but you're going to get rid of it so much faster because now you have infinity over infinity. So now what do you do to just the inside? L'Hopital.
Oh my
So
god.
just this,
One of the
just this.
badass.
1 to the 10th is, okay, don't lose, because that would suck. If you have 1 to the 10th is 1 and you lost this 1/10, you have to
Oh,
pick another.
shoot.
And we only have 3 today, and we've already used up 2 of them, so for sure something happened. Okay, but you don't have that luxury, so now we have taken the limit as n goes to infinity, and it is 1/10. Wait, so really nice, tricky ways around L'Hopitals for a whole long time. These, by design, should be matching up so that you can group them and just have to do it once to fall out instead of 10 times to fall out. All right, so now tell me, converge or diverge, state the test, state the condition. Okay. We're going to do one more ratio with factorial because most of you are going to need help canceling variable factorials. You guys look on your paper. If you told me that the absolute value of r is less than 1, that is not for this test. What is the absolute value of r being less than 1 for? Geometric. This wasn't geometric. What is the absolute value of? L. It's your limit. Okay, so pay attention. So you have converge. By what? Absolute value of your limit is equal to 1/10, which is less than 1. Okay, so please make sure you have L and not R in your paper. Okay, I want to do one with factorial because it's going to be thoughtful to make sure you guys know how to cancel factorials. Again, the ratio test, your free response on the AP, if they are doing an interval of convergence, you will have to start with ratio test. Like, that's just what it's going to be. Okay, last one. So 1 to infinity. Oh, this is going to be great.
I don't like it when you say things like
Oh my gosh, it's totally geometric, isn't it?
Oh my god, wouldn't that be
Definitely
awesome? Yes, and then you have n over n, which is 1, so it diverges.
Yeah.
Okay, so clearly not geometric. Yeah, you have infinity over infinity for the nth term test, but what's the problem?
The factorial and how do you take the
You have multiple issues. You have an n to the n, and you have an n factorial. And you don't know how to do the factorial derivative, so you're out on that one. Okay, your only option is the ratio test. Whenever you see a factorial, you should automatically jump to ratio test though. Like, I wouldn't even go through the checklist. Okay, so let's set up. So try to set it up on your own. You have 3 n's. All 3 of them will get replaced with n plus 1. Okay, so count your n's. That's how many n plus 1s you have. And this is our last example, if that keeps you motivated at all.
Yep.
It does me, like I'm a person who counts down, so.
Did someone see that there was something on Twitter that was like, what inspired you to write this essay? It's like the due date.
Yeah, for me that would have been the answer.
True.
Yeah.
There's a whole lot of numbers.
On the AP test, your first point comes from setting up the ratio test. So when you set up the ratio test, look on your paper, did you put the limit as n goes to infinity? Because if not, you're not setting up the ratio test.
Wait, where? Oh, right there.
Yes.
And R.
I skipped straight to dividing by the reciprocal, but I wanted you guys to see why. You guys, Muriel asked the question, can we skip straight to multiplying by the reciprocal instead of putting it over the whole thing? Yeah. Okay, I don't write it this over that and then change it every single time. It's this divided by my a sub n, so it's multiplied by its reciprocal. Okay, we've done some things and there are patterns that repeat. On the last problem, we had a 10 to the n plus 1. And what did we do with the 10 to the n plus 1? Okay, so traditionally,
n squared plus n.
So traditionally, if you've got like stuff to the n plus 1, write it as 2, or n plus 2, write it out as separate. So traditionally this so if you have an exponent with addition or even subtraction, and it doesn't have to be a 1, separate them. Because then you are going to see nice happy pieces that cancel. Okay, so side note, review on simplifying factorials.
I don't. Oh wait, I do remember.
Oh, crap.
That makes sense.
Okay, so 7 factorial over 5 factorial. 7 factorial is 7 times 6 times
5, 4, 3, 2, 1.
But instead of writing 5, 4, 3, 2, 1, I can just write. So you take the bigger factorial,
You subtract smaller.
you go down by 1 until you reach the smaller factorial.
42.
Okay, so when you're looking at it, the larger factorial, you start with it, you subtract 1 until you get to the smaller, write it with the factorial and cancel.
Oh, and
plus
plus 1
one
and
and
I
factorial
remember
is
just someone saying, oh, you can just write 5 factorial. I would definitely go 5, 4, 3, 2, 1, and like cross out each one of them.
Wait, so would that
So
just
not-
be with n plus
So
1
when you have n plus 1 factorial
and n factorial
over n factorial, which one is larger?
the n plus 1.
The top, because if you added 1 to n, it's clearly larger. So you start with the larger. Shh, here we go. You're going to want to see this. You start with the larger one. And you start with the larger, and you subtract 1 until you get to the smaller. So what happens when I subtract 1?
You get n factorial and then
You are already at the end, which now is at your smaller, so stop. Ah!
so much anger right
Ah!
The n factorial.
So you're just left with n plus 1 for fun. Alright, cool. Solid. Alright.
Okay, so when you are doing that, please be careful you decide which one is the larger factorial. You start with that. You subtract 1 until you get to the smaller factorial. You stop, and then the smaller factorials will cancel. Oh, no, there are really, really great algebra things that happen.
But I don't do algebra.
Well, you will. So, I'm going to write this, you guys. I'm going to spread it out so you see the whole thing. So, I'm going to group my factorials together. Shh. I'm going to group the factorial stuff into one fraction so you can see it canceling. And then I'm going to put the exponent stuff in the other fraction. So I kind of have like similar pieces paired together. So I'm just rewriting. I haven't done anything yet. So I'm just grouping, you guys. So all I did is group factorial stuff into one fraction so I can do that reducing as one piece. And then I grouped the stuff that had the exponents in my other. There are really, really good algebra things that happen. So what I would like for you to do in your groups, we just did this on the sideboard. Simplify that, combine it with the other, and there are really good algebra things that are going to happen. Okay, so keep going.
I don't. Don't the n plus 1 cancel? Okay. To the n plus 1 to the n. I feel like that should cancel. I don't know, that's just me.
I get like 1 to infinity.
No. But how did you cancel the? I'm having
All right, you guys, so let's get everybody to the same point. The n plus 1 factorial we just rewrote as n plus 1. Okay, so that's what we just did on the sideboard, you guys. Clearly the n factorials cancel. And now you are left.
So the n plus 1 by themselves cancel.
And now if you look, you have an n plus 1 on top and an n plus 1 on bottom.
Is it always going to work out this happy?
We are not at the end, which is not happy. So.
Whoa. Yeah.
Okay, so now we're here. Okay, so do you guys, so because they had the same exponent, group them like we just did. Okay, so tricks repeat themselves. Here you have infinity over infinity. L'Hopital's to the inside. What do you get on the inside when you do L'Hopital's? Infinity over infinity. Then you apply L'Hopital's. What do you get into the inside down? But you are still to the n, and n is going.
To infinity says, oh.
Yeah.
Okay, so when you do the problem, when you get to this point, you guys are still going to have to recognize indeterminate forms, and you're still going to have to be able to go back to the last chapter because this and the nth term test regularly require L'Hopital's. Okay, so if you had tossed out the 7 indeterminate forms from your brain, you're going to want to put them back in and make sure you know how to solve them.
No,
So we are.
LN.
Now we do ln because we have the exponent.
Could we have done infinity times 0?
That would have
LN of 1 is...
I wouldn't have wanted to do ln earlier because we were in like a happy state for derivatives.
So the answer is 0?
So let's split.
infinity times ln.
Okay, so now this is like your thought bubble. We still aren't done. You have to go back at the end. So I'm going to say we said L for limit was equal to the limit as n goes to infinity. This is how we wrote it when we did them before. Then you ln both sides because then the exponent can come in front as multiplication.
Oh, I did the wrong thing.
Yeah, okay.
Well, then
Those
I
are
get infinity
recycling.
over 0. But then I still get
Yeah, what are we getting? Infinity over 0.
after you do this.
And
part,
ln. Okay, n over n plus 1.
and yeah,
Which is then infinity times ln
You
of
see what I'm
infinity
saying?
over
So you
infinity.
get ln of infinity once you do it again, and then rewrite it, and we give it 1 over n, which is 1 over infinity, which is infinity over 0. So what?
1 over infinity is 0.
Okay, so I'm leaving the left-hand side.
But not the bottom.
So when you plug this in, you guys, we've already decided that this is 1 after you do it. ln of 1 is 0, so you have infinity times 0. We already knew this was coming. This is not going to the bottom. That is for sure going to the bottom. Okay. So you have ln. How do you take the derivative for ln?
It's the derivative of that in the inside time over the entire thing.
Okay, so it's the derivative of the inside, so it's going to be u prime over u. How am I going to do the derivative of this?
Using
You put 1.
quotient rule. Using v.
Quotient
Oh,
rule using b's.
Yes.
If you plug in the limit as n goes to infinity
Uh-huh.
right here,
Yes.
it's infinity over 0.
No, it's infinity over infinity. L'Hopital's is 1 over 1. ln of 1 is 0. So it's 0 over 0. This value is not
The
infinity.
derivative of the bottom though.
I'm still just trying to figure out what the top is going to when I plug in infinity. Like here when I plug in infinity, 1 over infinity is 0. So I'm like, oh, okay, that's the value.
Okay.
But when I plug in infinity here, I still
Yeah.
don't know the value.
Yeah,
This
okay.
one, this
Okay.
is awful.
It's not the greatest.
Over, what's it, because the derivative of 1 over, oh.
I think I only had to do the derivative once though, like on my notes.
Well, good, because it's like a 4 stacked.
But
Bundle
think
of
about all
joy.
the good derivatives we've reviewed. We've reviewed constants to exponent for exponential functions. We've now got to review the quotient rule. We've got to go back over indeterminate forms.
You say algebra before calculus.
Algebra before calculus for sure. So once you've done the derivative, do algebra before the calculus.
Okay, actually, it didn't turn out too bad. Not gonna lie.
No, I
Like, what we call that.
Wait, seriously, just edit that back there. I'm gonna stab something. All over. N over n plus 1. All over. Make the 1 over n squared. Oh, shoot. Yeah. I forgot to do something. I started to cancel. I don't know if I canceled right, because it turned out really unhappily.
I'm just done with this, but that was
So I don't know if I was like, thought I got it. I thought I got it, and then I got
No.
weird.
I got like
All the way back to the beginning. And that's not good. Yeah, and because then I got negative n over n plus 1, and that just screws this. I know.
Wrong way if you mess up once you're screwed.
I know.
I think my lines just.
Because doesn't it then end up being infinity over infinity, and you have to take the derivative again?
Okay, how tough is that?
No, but I was confused because you said you only take it once, and then I got so lost. And I was
Oh
just-
yeah, but for me, like that doesn't count as like a.
That counts.
Okay, so
you
Rin.
end up with n over n plus. I got it right the first time.
So
I
negative
just
1.
LN'd it way back, and it was easier.
You guys, that negative sign is going to be crazy important. Okay, so watch. So this is my u prime in terms of ln is u prime over u for its derivative. So for my u prime, I did the quotient rule. So the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. So that's u prime over u. So this is u prime on top over u. So this is just the ln stuff. And then your bottom derivative is negative 1 over n squared. I ignored that and simplified the top all the way down to here. And then divided by that is times its reciprocal, which yes, I will give you as infinity over infinity, but I am positive this derivative is not that difficult. What is your final answer?
Negative 1, and then you have to
Okay.
ln. I forgot words of truth.
Okay, so you have to finish it out. Okay, so from here, the reason why that negative is super important,
Convergence.
and actually I think I had L's over there in the problem before you guys. It is negative 1.
It's negative 1.
The negative is what pushes the e to the bottom, which is what makes it converge instead of diverging. If you add e to the positive 1, you're going to say diverge because the absolute value of your limit was greater than 1. When you have the negative exponent, it pushes it into the denominator. That's it.
Excuse me.
I
have a really
perfect. I just didn't get the e to the negative.
I'm gonna forget that.
Did you
like,
get from here to the negative? Do you see it now?
No, yeah, I got it.
Oh, got it,
I
got
did
it.
a different way.
She
And
did
I got
the
the
right
right
answer.
answer. I just didn't do the last derivative correctly. And so then I got confused.
I told you it's important.
Okay. All right. So final answer is converge by ratio test. My limit is equal to 1 over e, which is less than 1. Okay. Geometric series you guys should be totally proficient on. Nth term test, look ahead a couple derivatives. If it's not getting better in like a decently quick manner, go on to the ratio test. So the ratio test isn't always enjoyable.
Whenever, even if. Like,
Yeah, but it's so much work
yeah.
that when it equals one, you're like, ah, crap. And then if you find out that the nth term test was really fast,
Yeah,
people are like, how do you know? Well, geometric, you know. But for the other two, I kind of look ahead a couple of derivatives to see if I'm going to go in a good direction or not. First of all, do I know how to take the derivatives? Secondly, are they ridiculous or are they decent?
Yeah.
And am I eventually going to get something that I can say, oh, this is the answer?
Okay.
All right, you guys. Tomorrow we have more fun-filled activities, but you guys have over half an hour, so it's a decent amount of time. Grab new assignment sheets if you did not already.
How cold did you want?
I'm getting excited for it. For what's upsetting? My birthday's in 9 days. I'm not excited.
You should be excited.
Why?
Because it's just
To be trained?
step closer to independence.
I kind of want to stay away from that right now. I'm a little scared for that.
Well,
You paying for college?
Paying for college, paying for an apartment,
Paying for everything?
paying for my life. Is that the only one we have? Oh!
Prior.
Yes, ma'am.
can you scroll back up on the right side. Oh, right, you could probably stop videoing. Maybe Kate wants to see it scroll up too.
Okay.